Notebook out. This is the 3-6 takeaway. Just get a separate sheet of paper. I don't want a bunch of people going in and out. So again, the big one, the new one, is angle addition postulate. The difference between the angle addition postulate and the segment addition postulate, the angle addition postulate, we're adding angles. So the idea is this angle, we'll call it angle A, B, C. We could turn this figure into an equation, and it's something that we could easily prove by saying angle ABD plus angle DBC equals angle ABC. So if you're just hearing me say all that nonsense without looking at what I'm talking about, it's going to be very confusing. Angle ABD plus angle DBC equals angle ABC. I don't even know what the heck I said. But when you look at it, it should make sense. ABC, this angle, plus this angle equals the whole thing. That should make some perfect sense. Let's look at an example. You'll see something like this. Let's say angle ABD equals 52 and angle ABC equals 109. What is angle DBC? Say it again? Yeah, but wait. She said minus. I thought this was an addition. Well, you got to use your big brains, right, to understand that this smaller one's 52. This is the one we're looking for, and ABC is 109. So if we were plugging in, it would be 52 plus I don't know equals 109, and then I would subtract over 52, and I would have it after some quick math. What's the answer, by the way? 57? Yeah. So that's angle addition postulate. We'll do that so that we can get this into an equation, right? Something we can plug in, solve, plug in what we know, solve for what we don't. Most of the other stuff, most of the other properties that we see in here are properties or definitions that we've learned before. For example, what's supplement mean? Supplementary. What's supplementary mean? $180, yeah. That's where you have two angles that add up to 180. That shows up here. Complementary. What's that mean? Come on, guys. Yeah, it's when the two angles add up to 90. What do we know about vertical angles? What do we know about vertical angles? Yeah, they're congruent. Okay, they'll have the same measure. They're the same value, right? Vertical angles. So angle 5, angle 6 are vertical. They share a vertex. Their sides form opposite rays. A fancy way of saying, once you see that X, right, they are across from each other, not adjacent to. That would be adjacent to, right? They would be vertical or across from each other. All right, and then I think the last one, linear pair. What do we know about linear pairs? What do we know about linear pairs? They're on the same line. That's the idea of linear, right? What else do we know? Linear pairs are adjacent, which means they share a side. They form a line. That's the word linear. That's what that means. And what do we know about the sum of angle 7, in this case, angle 7 and angle 8? Yes, they add up to 180. A line, an angle, a straight angle, which would look like a line, has a measure of 180, so a linear pair is a pair of angles that add up to that 180. All right, there's some more things in this chapter, in this section. If we come across them, I'll reteach it or reiterate it at that time. So our assignment is page 203. We're going to do 1 through 8. And 13 to 18. All right. Just about ready. Okay, number 1. Here we go. So ABC, guys, be quiet, please. ABC, this whole thing is what we're looking for. It gives us DBC as 43. And then it gives us ABD, also it gives us ABD, this whole thing, as 70. That BE we don't really need right now. Okay? Ignore that for a second. What is angle ABC? It's whatever 70 plus 43 is, right? 113. Do you guys agree? Yes. Man, that's got to be a lot easier than those proofs, huh? For real. Okay, next one. Rapid fire, see if we can do these. All right, number 2. EBC, so that's this guy, EBC is 55. And EBD, so that's the little guy in there, EBD is 20. Find this guy right here. So the whole thing's 55. Part of it's 20. Nope. The whole thing's 55. Part of it's 20. The other part would be? You said it. 35, yeah. So the idea is it's 20 plus something. I don't know what that something is. Subtract over 20 and we get that something, that X, that unknown. to equal 35. We got it? Here we go. Moving on. All right, number 2, EBC. EBC is 55. We're wanting to find angle 2 again. Wait, that's the same thing. Sorry. Number 3, ABD is what we're looking for. ABC is 110. And angle 2 is 36. So is the whole thing 110? Is this right? So when we subtract over, what do we get? Good. Everybody agree with that? I don't have the figure in front of me. All right, good. Why don't you guys try... Oh, I'm sorry. Number 4. Next page. For me, it is the next page. Okay, number 4. Here's what we got. How do you describe these angles? Huh? Yeah, they're supplementary. They are not vertical, not complementary. They can't be complementary and supplementary. Guys, they are adjacent. That's a linear pair. Okay, we just talked about that in our takeaway. So if angle 1 is 112, what's angle 2 if it's a linear pair? Linear pairs have to equal what? 180. Angle 1 is 112, angle 2 we don't know. The whole thing I know has to be 180. So, use your fingers and toes to figure out what that is. Yes. You got it. Good. All right. Complementary is what I'm hearing. Yeah, if you look here, might be a little hard to see. But it gives you this little square indicator there. That square indicator means 90. Means we're going to have a complementary idea. We don't know what the measure of angle 1 is. That's what that M stands for, by the way. We know the measure of angle 2 is 44. We need to find the measure of angle 1. It is what?
46.
Madison!
46. I told you it. No, you didn't.
Good job. Yeah, you guys should fight. I'm just kidding. Don't do that. But hey, I like the moxie.
Houston, fight Carter. I want to see that.
Yeah, Carter's killed.
Make him look like a pillow.
All right, number 6, 2-column proof. Here we go. Number 6 is a 2-column proof. How do you do it? I mean, like, what do you start with? State the given.
Dude, these suck.
Everybody should be able to do this.
What? We gotta do the little cross thing.
Everybody should be able to set up a 2-column proof. State the given.
I really thought we got away from this. Yeah.
Not yet. You're going to see, guys, you're going to see proofs, at least 1 or 2, probably every chapter from here on out. Yeah, I mean, we might not always address them, but they come up. Okay? Yeah. Okay, we have to prove that angle 1 is congruent to angle 3. It's given that angle 2 is congruent to angle 4. What else do we know that hasn't yet been stated? Let's get an equation on paper. Yes. Just shot in the barrel. Go.
Angle 1 plus angle 3. 4. 2.
All right. What do we know about angle 1 plus angle 2? They equal 90, right? What else do we know? What do we know about angle 3 and angle 4? They equal 90, right? That's what that indicator means. And what word tells us that? What does that mean? It's a right angle. Okay. It equals 90, right? It's a right angle. We know that. Yes, PJ?
So is the idea then to, we say that the whatever angle isn't stated to be 90, so for instance, that would be, yeah, if we know it's gonna be hard to verbalize.
Yeah, it is.
Yeah.
This is the complement theorem. So when I ask you what word means that two angles add up to equal 90, what I was looking for was the word complement or complementary. And your book calls this the complement theorem. The word theorem, all that means is it's a rule that's been proven. So we can use it. It's already been proven. We can use it. That's not how you spell it, is it?
What are you talking about?
Is that better? Compliment? Try to sneak that letter in there. Okay. So, what do we do next? What else do we know? Maybe we can build from this equation. What else can we do? Switch what around?
They both equal 90, so can't you just
Hey, guys, stop with the side conversations. I mean, this is something we should know how to do. I mean, it's like screaming at you here. They both equal 90, right? Some of you guys are starting to get it. Add them? Is that what you said?
Never mind then.
If these equal the same thing, right, I can set them equal to each other. I can use a, what's the property called? Yes, substitution. I can use a substitution to say that these guys are equal. So the complements theorem will get the equation on paper, right? Get us something to start with. And then we just substitute from there. This is something that we did with our segments. Proofs are hard, but there's a lot of repetitiveness in proofs, just like anything we do in math. Okay, now what can we do? We need to probably plug something else in, right? Well, they give us something. We're trying to prove 1 and 3 are congruent. We almost have it. If we could just get rid of the angle 2 and angle 4, we'd be done. Can't do that yet until... Can't subtract yet until... I don't know what angle 2 minus angle 4 would be until I... I don't know what that would be. Yet. Have we used the given yet? I mean, have we done anything sort of substitution-wise with the given? That's usually the next step. If you've been focusing on what we've been doing in the last section. We get the equation on paper, we do a substitution, and then we do another one. If angle 2 is congruent to angle 4, in place of angle 2, I could put angle 4. Now I could subtract them. So I do a substitution again. Then I can subtract them. So you guys were just a little bit ahead of yourself. I got to make sure angle 4, when I subtract, it cancels out. So now I have it. Angle 1 will be equal to or congruent to angle 3. I'm done.
Wow, that was.
That's a lot of work.
That's one I would expect you guys to be able to do.
Hope I got it all out.
It's very similar to what we did last section. Okay, number 7. All right, no whining. Set it up. Proofs are hard, but the first part is so easy. Give me a break. Everyone should be able to do that. Unprompted, no problem.
Jesus Christ, buddy. Got that hard, boy.
Here's the figure. What do we know about 3 and 4? What do we know about 1 and 2? That would get it on paper. It's very similar to this, only the equations, they're a linear pair, which means what? What do we know about 3 and 4? When you add them up, it equals 180. What do we know about 1 and 2? Yeah, they're a linear pair. When you add them up, it equals 180. Okay, do you see how 6 and 7 are going to be very similar? We use a different number. That's okay. What word tells us that? You guys were using linear pair, which is really close, but if the number 6 was the complement theorem, what do you think number 7 is? Yes, supplement theorem. Okay, they want angle 2 and angle 4 to be congruent. That's what we're looking for. That's what we're shooting for. Somebody raise their hand. Tell me what the next step's going to be. It's not subtract. Tell me what to write here in the statements. Skylar, what do you think?
Angle 3 plus angle 4. Because I can't tell if this is angle.
It's angle 1.
Angle 1 plus angle.
You don't understand how happy that makes me. Thank you. Yes. Guys, you can do this stuff. Okay? The reason. What's the reason? Someone over here already said it. What's the reason? Substitution. Proofs are hard, but they're not impossible. I love teaching difficult stuff. It's a lot more fun.
I don't like learning it.
I know. It's not fun at first, but man, you get a great satisfaction from learning something that is considered difficult. Okay, now what? What would I write next, and why? Dane.
You gotta like find like the L2 and the L4. You gotta like find out something.
Okay, that's angle 2 and angle 4. So you want me to write down what you said? Like, tell me what to write. What would I write?
You gotta just guess.
Angle 3 plus angle 2.
Okay, Carly. Angle 3 plus angle 2
Equals angle 4 plus angle 1.
equals angle angle 1 plus angle 2. look at what I did. Some of you guys are starting to get it.
I'm starting to.
Okay? In place of, wait, back up. What'd I do? I screwed this up. Okay, back up, back up, back up.
Oh, man.
I think Carly was trying to correct me, and I did it wrong. Yeah. In place of angle 1, I'm going to put what angle 1 equals.
Oh, you're asking for it.
That's a substitution.
What does that say?
What do you think it says?
I'm looking at the last one.
What do you think it says?
C2?
You think is that a C that I've been writing?
That looks like a C.
Angle. It's an angle symbol.
Oh.
You guys get too hung up on what I'm writing down and trying to read it, and you don't engage your brain and try to just use some context clues, right?
My brain never.
Yeah, I hear you.
However,
Then we know.
So funny, guys. You should continue to make jokes.
Loading this bit.
Okay, angle 3 plus angle 4 equals angle 3 plus angle 2. What do I do next? Yes. Subtract the 3's, yes. You can subtract the 3's, which would cancel that out. Boom, gone. Boom, gone. Why would I do that? Because then I'm left with angle 4 equal to angle 2 because of subtraction, and that's what I'm trying to do, right? That's what I'm trying to prove. So, boom, done. Problem equals solved. Exactly. Thank you. Makes me. You guys are starting to get it. Proofs are hard. They're not impossible. Okay. Scrolling down.
There's more.
We don't do 9 and 10. We're just okay. 8.
I was down 1 to 10. No, it's 1.
Set up the 2-column proof. I'm going to get you going the first couple steps, and then I'm going to let you take off. Yeah, I think you can do this one on your own.
Today, but no.
Be brave.
I don't want to be.
Yeah, Julia's kind of already got it. Julia, I mean, take off. You can do this. It's a wonderful thing. All right, we're trying to prove angle 5 is congruent to angle 8. We can't do that until we get this equation on paper. It's given that angle 5 is congruent to angle 7. We're trying to prove angle 5 is congruent to angle 8. We have something going on here. Something that we know that hasn't yet been stated. No, it's not supplementary. It's not complementary. It's vertical. Okay? From the takeaway, there was a few things that I pointed out, all right? Like complementary, supplementary, linear pair. I also pointed out vertical angles, right? And what do we know about these vertical angles?
Go straight up and down.
They are congruent. So state that. Your first step is state something that we know that hasn't yet been stated. A lot of times, that's some sort of equation. So, vertical angles theorem. So, trying to abbreviate there. All right, a couple different ways you can go about this, but based on what we did last section, based on what we've done already today, what do you think we're going to do next? Some sort of substitution, right? So, we look at what we know, we look at what they've given us. What do you want to try? Shaden?
Angle 6 plus angle 8 equals angle 5 plus angle 7.
Not quite. You might be right, but it's not necessarily It's not necessary to add these in this case. Okay. It was necessary on complementary and supplementary because that's what those theorems say, right? It says you got to add them up, like whatever. Okay. But the vertical angle said they're just congruent. So we don't. There's no need for us to add stuff together. Although you could, and you might be able to get there from there. There's a more efficient way to get there. Let's start with this angle 6. What else do we know about angle 6? What else is it congruent to? 7. Why? Since 5 is 7, anywhere I see a 5, I could put a 7. Right? Huh? Substitution. Yeah, we're trying to get that 5 and 8 are congruent. We haven't quite got there yet. What else do we know?
8, 5, 5 and 8. What is that?
5 and 8 are congruent? I mean, we will eventually get there.
5 and 6.
But, like, I can't just substitute 6 for 5. Well, yeah, I could.
Oh, man.
Is that who just said that?
Kate,
Yes, you could, right? So, yeah, of course. So I could substitute here. Instead of writing 6, I can write what 6 equals. What's it equal? Nope. I'm trying to get this right. Yeah, 6 equals 7. I know that, right? But I'm trying to get to this. 6 equals 5. So let's go ahead and write that. I do know that. Instead of writing 7, I could write 8. That's what I'm trying to get to, and that's true, right? I can substitute those in.
Figured it out, Carter.
And that's a substitution, which I'm fine with. Your book probably will call it a transitive property, which, technically is true, but we've learned that as a substitution, which I'll take. All right, and then we're done. Sweet. Cool. Yeah, once we're done with once we get to our prove part, we know we have reached the end of our proof. Okay, we do have 13 to 18, so we have a little bit. No, we don't. We don't have a ton of time. Okay, let's look at 13 real fast.
You should only make us do like 13 through like 16.
Okay, on 13, what do we know about 6 and 7? What do we know about angle 6 and angle 7? They're supplementary. Substitute in or plug in, instead of writing 6, write what 6 equals. And then we need to solve for x. That's how these are going to work. First, ask yourself, what do you know about them? And then that'll tell you where to go from there. They won't all be like this. But knowing the complements theorem, knowing vertical angles theorem, knowing supplements theorem will help you do these, okay? So do what you got to do to solve for x, and that'll help you find the answer. By the way, so it wants to know, what does angle 6 equal? What is the measure of angle 6? What is the measure of angle 7? What is the measure of angle 8? That's how you answer these questions.
Come on.